Okay, here we have a word problem involving partitions, and we're going to use Venn diagram to solve the problem. And the problem reads, there are 50 students at a house party. 35 of them are drinking Jägermeister, 20 of them are drinking Natty Ice, and 15 are drinking both and are probably going to die. We're trying to solve for the number of students drinking neither Jägermeister or Natty. So here we have our universal set, which is the rectangle. Then we have the number of elements in that set in the universal set, which is 50, which is the number of students at the party. There are 50 students at the party. And then we have sets A and B, okay? And I'm going to make set A Jägermeister. And I'm going to make set B the number of students drinking Natty. And you don't need to use shading to solve this problem necessarily. I'm just going to do it to help give you a better visual representation of where these students are. And so set A, we have all the students at the party drinking Jägermeister here. And then set B, we have all the students at the party who are drinking Natty. And in our intersection here, we have all the students drinking both, the students that are leaving in an ambulance. Okay, so let's just write 15 in here. Whenever you're doing these problems, you always want to work from the inside out. And the reason why that is because you have 15 students drinking both. You have up here, you have a total of 20 students drinking Natty. And you know that you have 15 drinking both Jaeger and Natty. So that accounts for 15 of the 20 students drinking Natty. So you know that, well, if there's 15 in the intersection, you know that there can only be 5 left. And then B, which is all the students drinking Natty, that now is 20. Okay, and you go over here and you do the same thing for the number of students drinking Jägermeister. You have 35 total students drinking Jägermeister, 15 drinking both Jaeger and Natty, which is going to account for 15 of your 35 drinking Jaeger, so that leaves 20 students just drinking Jaeger. So here we have 20 students only drinking Jaeger, 15 drinking both Jaeger and Natty, and 5 drinking only Natty. So that totals up to 40. So I'm going to write that up here. You have a total of 40. Okay, we know that there are 50 in our sample space altogether, 50 in our universal set. So obviously there's a difference of 10 there. There's 10 students unaccounted for, and we're trying to solve for students drinking neither. Obviously, if these are all the students drinking Jaeger, Natty, or both, there's 10 left, which must be drinking. They could be drinking anything else, or they could be drinking nothing else. Either way, they're represented out here as the 10 students drinking neither of these, and that solves your problem.